My name is Shanshan Chen. I'm currently an associate professor at the Department of Biostatistics at the School of Public Health at Virginia Commonwealth University. So I do a lot of research on using wearable sensors, right? So one of the big type of wearable sensor is to collect activity, and usually after 7 days, researchers would call this type of data actigraphy, right? We developed an algorithm in early 2019, where we use that to detect the sleep-wake cycles. That algorithm was run on, a relatively smaller sample. We run that algorithm on a dataset of about 150 children's actigraphy. So after that, I was wondering if I can apply this to other type of actigraphy data. And the idea is that the algorithm can be readily used or applied to other type of actigraphy data because it's designed that way. So I was really trying to find a high quality actigraphy data set that has a much larger cohort and ideally have the event markers so that I can validate whether my detection results was correct. So I found NSRR through other people's research and papers, and then that leads me to NSRR. First, as I said, I was just trying to get a large cohort of actigraphy data. I found the MESA sleep dataset, and I have used that extensively in my work. But also during this research, I gradually realized that we also need to learn I also need to be able to understand the polysomnography side of things in order to better understand the sleep. So I start exploring in the same data set, and luckily the polysomnography data on NSRR is well documented, and you can also do some visual exploration to see all this time series of polysomnography and how people actually through the night. So I have now just scratched the surface, which is the sleep hypnogram data. As the first layer of sleep architecture. I also used the MESA sleep dataset to do that. Currently, my work focused mainly on the methodology development. So we're trying to develop generalizable and reproducible methods in order to analyze this sleep data, whether it's actigraphy or polysomnography. For example, in the actigraphy case, right, we developed the algorithm called CP, which means circadian rhythm based change point detection algorithm. So the algorithm is, kind of a first principle based algorithm, which means you don't need training labels in order to be able to do the detection. So this method can be used to actigraphy that's generated by different sensors collected on different populations and on different wearing locations. If you worked with actigraphy, you know that different manufacturers of activity sensor would usually give you different scales of activity counts. So how do we actually reliably and unbiasedly estimate the sleep-wake cycles is a big question. And hopefully my algorithm has addressed most of the issues with that problem. Yeah. And in the future, we're hoping to apply our methods to study health issues. So to study the connection between the sleep and various health issues by taking both account of the circadian rhythm and the polysomnography type of data. I would recommend just to keep a open and curious mind. For example, I wasn't thinking of studying polysomnography when I first encountered NSRR. And now it's my go-to resource for sleep data that are related to various health issues. Another recommendation is that I would start with a small and clear problem. The dataset can be really extensive, so one can easily get lost without knowing what to do by just exploring the dataset. Um, and lastly, I would say take some time to understand the data generation or data collection process. NSRR has done a great job to harmonize the data so that if you move from one study to another, the data structure are relatively consistent, which gives the researchers opportunity to easily move from one study to another. But I would say each of the study are unique, right? So understanding how the data were collected in each study will eventually help you to interpret and understand their results better.